So here's the task. Using this video, calculate the acceleration of this Airbus A320. Now the takeoff speed of this plane is 275 kilometers per hour, which is round about 171 miles an hour. What I want you guys to be thinking about is what equations are we going to be using and what assumptions are we going to be making. So now stop clocks on the ready and let's do this. Start timing right now, and we can see that the plane is already accelerating. The takeoff speed is 171 miles an hour, so this plane is going to hit some real high speeds real soon. You can see in the background that the plane is starting to move very fast indeed. We are well into over 20 seconds. You can see the wing is actually moving as well, and now we're moving at some very fast speeds, and I think we're approaching takeoff, and yeah, we have takeoff. So hopefully you guys have timed this. Now, as the plane is moving higher in the sky, what I want you guys to be thinking about is the equation v is equal to u plus at. In this equation, v is the final speed, the takeoff speed of 275 kilometers per hour. U is the initial speed of 10 kilometers an hour, which I've assumed to be so because the plane was moving a little bit. It didn't start accelerating from a complete standstill. What we need to do is rearrange this equation for the acceleration. We'll also need to convert the kilometers per hour into meters per second. T is the quantity. Oh, look at that view, how amazing. T is the quantity that we've already measured. Okay guys, so let's go to my digital whiteboard where we can do this calculation. Welcome to my digital whiteboard. Here's the equation that we're looking at once again. V is equal to u plus at. V is the takeoff speed, 275 kilometers an hour. U is the initial speed, run around 10 kilometers per hour. And T is the time that we've measured, which is about 35 seconds. And I've measured this directly from the video. Our first job would be to rearrange for the acceleration. So the acceleration A will be equal to v minus u divided by t. Now v minus u, that's 275, take away 10 kilometers per hour. So this will be equal to 265 kilometers per hour divided by 35 seconds. Now before we can proceed, we need to convert the kilometers per hour to meters per second. So this means that in order to do so, we need to multiply by 1,000 because 1 kilometer contains 1,000 meters, and we need to divide by 3,600 because 1 hour contains 3,600 seconds. So this will be equal to 265 times 10 to the 3 divided by 3,600. And now let's just divide by 35. And if we put that into a calculator, we are going to get 2.1 meters per second squared of acceleration. It is also really important to discuss the fact that this equation assumes that the force applied onto the plane is constant. The force generated by the engines is constant, that the throttle does not seem to be changing the amount of thrust provided, which, judging by the noises in this video, the engines seem fairly constant, so I think this is a perfectly valid assumption. But back to our original question, which was how many g's of acceleration do we experience? Now let's just calculate the fraction. Let's just write down the 2.1 meters per second squared divided by 9.81 meters per second squared. Well, 2.1 over 9.81, this is simply 0.2 0.21. So the answer is that during takeoff, a normal takeoff that I've just experienced on Airbus 308, 320, I've only experienced 0.21 G. So this is tiny, and this is precisely why I was able to hold the camera basically uninterrupted during takeoff so I can get this footage. Okay guys, hopefully you found this video useful and fun. You can certainly apply physics in a lot of very fun situations. If you found it useful, please give it a thumbs up and consider subscribing. Thank you very much for watching, and I'll see you in the next video.